All right, now we're solving equations. And for this one, what jumps out at me is that this would be very, very easy. My goal is to get the x out of the denominator, but it's very easy to just move this 2 over by subtracting 2 from both sides. And then I have a fraction equaling 1. And listen, hopefully it's easy enough that you can look at this and tell me that x equals 0. But if you can't, then you can solve this by getting rid of the division by multiplying. You're going to multiply by what you're dividing by, so that's going to be x plus 2. And whatever you multiply by on one side, you have to multiply by on the other side. So we have 1 times x plus 2, which is x plus 2. Over here, these cancel, equals 2. Subtract, and you get x equals 0. And that's an okay answer. We can have 0 down there in the denominator because you're adding it to 2. All right. Over here, before we can do anything, we need to get rid of these parentheses because this x is trapped inside of these parentheses and this x are trapped inside of these parentheses. So over here, this means 2x plus 1 times 2x plus 1. Over here, I have to distribute the 4 all the way through the parentheses. Here, I'm going to distribute 2x and then distribute 1. And then combine up my like terms. So my left-hand side becomes 4x squared plus 4x plus 1. And my right-hand side is 4x squared plus 4x plus 4. And since we have an x squared, we're going to solve this by factoring, which means I'm going to move everything over to one side. So we're going to subtract 4x squared, which is going to leave 4x plus 1 equals 4x plus 4. And then we're going to subtract 4x, which is going to leave 1 equals 4. And we talked about what this means back on Monday and Tuesday when we did our activity in class. When all your variables drop out and you end up with a false statement, 1 does not equal 4, this is false, then what that means is there's no solution. And you have to write no solution. If you leave it as 1 equals 4, I'll mark it wrong. If you write false, I'll mark it wrong. I clearly know that's false. You have to tell me there's no solution there, so make sure you do that. All right, and then here, again, the clue is the x squared, so I'm going to have to factor this, which means it needs to be equal to 0. I'm actually going to move this over to the right by adding x squared to both sides and subtracting 8x, because I don't like dealing with a negative x squared. So once I get that all moved over, then I'm going to try and factor, because that's the whole reason I did that. And this factors into -6 and -2. And then using the zero product property, I can take each of these and set them equal to 0. So I get x equals 6 and x equals 2. And then here, you could square this if you wanted to, but why don't I get this x out of this power of 2 by just taking the square root of both sides? Then those will cancel. Remember, there's lots of ways to solve these problems. You could certainly do this a different way, but try and think of the way that does it the easiest for you. A square root of 44 is a plus or a minus. And then the square root of 44 breaks up into the square root of 4 times the square root of 11, so that's 2 square roots of 11. And then I still need to get x by itself, so I'm going to subtract 7. And of course, on the right-hand side, we can't combine something with a radical and something without a radical. So it's going to be -7 plus or minus 2 square roots of 11. And then to finish this up, we're going to divide by 4, and we're going to divide this whole thing by 4. Make sure your fraction bar takes up everything. And this is a fine answer. Now, some of you may recognize that the 2 and the 4 are both even, so we can reduce those. And that is indeed true, but remember that you also have to take this -7 and divide it by 4. So if you're going to decide to do that, make sure you indeed divide both of those by -4. So if you're breaking that up, this is what it would look like. I don't care which way you write it. All right, going on to the next page. Here again, we have an x squared, so I'm going to try and factor that. It's already set equal to 0. X times x. And then I need two numbers that multiply to give me 14 and add to give me 8. There's nothing. My only choices would be 14 and 1, which doesn't add to give 8, and 7 and 2, which doesn't. So this does not factor. So I'm going to have to use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And again, make sure your fraction bar is covering everything in your numerator. So we have negative 8 plus or minus the square root of 64 minus 56. 4 times 14 is 56, all over 2. So negative 8 plus or minus the square root of 8, all over 2. And then, of course, 8 breaks up into the square root of 4 times the square root of 2. So we have negative 8 plus or minus 2 square roots of 2, all over 2. And unlike the previous one where I said I didn't care if you broke it up, this one you would have to, because both the 8 and the plus or minus 2 square roots of 2 are divisible by 2. So you do have to simplify this and say negative 4 plus or minus the square root of 2. Up here, my issue is my x is trapped underneath my radical. So I need to get rid of that radical by squaring both sides. But before I can square both sides, I need to move that over. So I'm going to add 3 to both sides. And now I can go ahead and get rid of that radical. You can't square it with the 3 there. If you square it with the 3 there, you're ending up with a middle term, because you would be taking two things and squaring it, and you'd have to rewrite it and FOIL it all out and everything. So you have to isolate that radical first. Then I'm going to move the 5 over, divide by negative 1, so x equals 4. And then I just mentally checked that really quick, and it does work. So there is my solution. All right, now for this guy, we have, again, the x trapped inside of this exponent. So in order to get rid of the exponent, the easiest way to do that is to raise both sides to the reciprocal of that exponent. Because what happens is when we raise a power to a power, we multiply those exponents, so it all cancels out. And over here, we're taking the square root of 16 and then cubing it. Well, the square root of 16 is plus or minus 4, and then cubing it. So we get plus or minus 64. You have to put the plus or minus on right when you square it. You can't do one equation and then at the end just go ahead and tack on a plus and a minus. So we're going to have an equation that equals positive 64 and an equation that equals negative 64. So we get x equals negative 66 and x equals 62. And then for our last problem here, we have an absolute value. So we have to write this as two separate equations. One that's in the positive direction. So when that happens, the only thing that happens is we just drop the absolute value symbols. And then the other one in the negative direction, we're going to take the negative of that whole side. So both of these are quadratic. So I'm going to get it set equal to 0. So we have x squared plus 3x minus 18. And then factor. And then set equal to 0. and then check it. So 36 plus 36 is 36. 36, or 6 times 3 is 18. That's it. So that works. 3, 9 plus 18, and 9, yep, that works. All right, now we're going to come over here, and we're going to distribute that negative. And then we're going to move the 3x and move the 18. So we have x squared plus 9x minus 18. And then that does not, wait, plus 18. Sorry, that's plus 18. Add 18. That does, oh, nope, that factors as well. X minus x plus 6, x plus 3. So we get x equals negative 6 and x equals negative 3. I'm going to check those. Negative 6 is 0, Negative 3 is 0. Uh-oh. Negative 3 is not 0. It's 9 and 9. Okay. So both of those also work. And it's just a coincidence that these ended up being opposites of each other.